Hey friends, welcome to day two. Hope that homework last night wasn't too bad. Electrostatics 101, dealing with charging by friction, the universe being electrically neutral. Um, Definitely check out the lightning too. Definitely check out the key. The key should be posted now for yesterday's homework, so you should be able to see the answers to that. This chapter is nice. There's no math. We're going to talk a little bit about numbers today, but there's really no math in this chapter. So we've coming off of, oh gosh, a couple of those chapters with momentum and all the M1 V1 equations, and then energy with the MGH and the 1/2 mv squared, and then even fluids. We're coming off of 3 chapters with a lot of math. This chapter has no math in it. It's just conceptual. It's a great chapter for us to kind of come back down and talk a little bit about a new topic, electrostatics, without the heavy math. So what are we doing in day two today? Again, make sure, since we're not going over the worksheet together, make sure you look at the key to the worksheet. Make sure you understand that. There won't be a quiz this week, but we will see these things on the test next week. There won't be a quiz, but you will see the things on the test next week. The quiz for this unit is out. There will not be a quiz this week. There'll only be the test next week. So we're going to do next week lab activity, a review, and then we're going to get ready for your test. So again, no quiz for this unit Friday or next week, just the test the following Friday. So a week from Friday, okay? You guys are probably getting ready for the PSAT tomorrow. So let's just get through this. The homework tonight's not very long. Knock it out before you leave today. I'm making the homework due today before you leave school at 3 o'clock. So there's nothing to do tonight for the PSAT, okay? Get it done, be done, and you should be fine. So I'm gonna go through a quick little lesson here, and then you should knock out your, we'll call it classwork, really not homework. Get it done before you leave and be done. Again, the quiz will be totally out for this test. You'll have a test a week from Friday, okay? Lab next week, test next week. Electrostatics day two. What we're talking about today is force. So again, opposites attract, likes repel. Just some examples. Determine the direction of force So what does that C? Charge is measured in coulombs. Charge is measured in coulombs. So what are the units of charge? Coulombs, capital C. But get this, 1 coulomb of charge is a lot of charge. A lightning bolt is like 10 coulombs of charge. So 10. So 1 coulomb even is a lot of charge. When I rub the balloon on my hair, I don't even have a coulomb of charge. I've got microcoulombs. So very, very little, or nanocoulombs. I have very little amount of charge. But for easy numbers, I'm just going to say -2 coulombs, +3 coulombs. That's a lot of charge. But that way we don't have to do with pico or nano or micro. We're just conceptually trying to get a feel for what's happening here. If I have a -2 coulomb charge and a +3 coulomb charge, I have a positive and negative. We just want to talk about what's happening to each charge due to the other. What direction is the force on the -2 due to the 3? Like, what does that 2 want to do? So I ask myself for this, what does the 2 want to do? Like, does the 2 want to go to the right towards the 3? Or does it want to go away from the 3? Is it attracted to the 3 or is it repelled from the 3? Well, back to it. Since opposites attract and likes repel, the direction of force, you'll see this on the test next Friday, the direction of force that the 2 experiences is to the right. The 2 wants to go right. If this question in your homework says, determine the direction of force on the positive 3 Coulomb charge due to the negative 2, it's going to be a different answer. The amount of force is equal and opposite. Do you remember the third law? For every action, there's an equal and opposite reaction. For every action, there's an equal and opposite reaction. So the 2 is wanting to go one way. The 3 is probably wanting to go the other way. Because what happens to the 3 is because it's positive, it's being attracted to the 2. That doesn't mean, well, eventually they'd run into each other. But if I held them, that positive and negative, I'm going to let them go. They're going to want to go to each other. Opposites attract, likes repel. So what direction is the force that the negative 2 is experiencing due to the 3? The 2 wants to go right. What direction is the force on the 3 due to the 2? Like, what does the 3 want to do? It wants to go left. So what does the 2 want to do? Go right. What does the 3 want to do? Go left. And you're going to see how this is going to directly apply to your homework. What if I had a negative 3 and a negative 4? And I said, determine the force on the negative 3 due to the negative 4. Well, now, oops, negative 3, I should probably write Coulomb charge. Negative 3 Coulomb charge due to the negative 4 Coulomb charge. Again, these are massive charges. But just to get an idea which way this is going to go, now I say, hey, look, these are light charges. They're both negative. So what direction does that 3 want to go? The negative 3, does it want to go towards the 4 or away from it? Well, the 3 is going to get repelled this time. If I said determine the direction of force on the 4 due to the 3, what direction is the 4 going to want to go? Well, the 4 is also repelled from the 3, so it's that way. All you're doing in your homework today is trying to figure out the direction of forces on charges due to other charges. So what does the 4 want to do? It wants to go right. What does the 3 want to do? It wants to go left. What if they were positive 3 and positive 4? Yellow is kind of a bad choice, right? I can't really do black and yellow because that'll look like Bishop Moore, so I don't really want to do that. Okay, so positive 3, positive 4. What about these? Well, guess what? The answer is the same. Because they're like charges, opposites attract, but likes repel. The positives will move away from each other. Negatives will move away from each other. So what direction does the 3 want to go? It wants to go left. What direction does the 4 want to go? It wants to go right. They're repelling. Soon we're going to be in magnetism. We're going to talk about a north and a south, opposites. North and north, when you make the magnets push off of each other. If they're like charges or like poles for magnetism, they repel. If they're opposites, they attract. So if it said determine the force on the 4 due to the 4 wants to go right. Determine the force on the 3 due to the 3 wants to go left. Does that make sense? And really, we're just getting direction. What I do with force is I say, what does this one want to do? Does it want to go towards the other charge or away from it? If I want the force on the negative 4, does that negative 4 want to go towards the 3 or away from it? Away. So it's going to be right. All right, that'll get you through the first 2/3 of the homework. The last third deals with like 3 charges. So let's go ahead and do this one. We're going to do one more example. One more example. Determine the force on the 3 due to the other charges. Well, what does the 3 want to do? Does the 3 want to go towards the 6 or away from it? It wants to go away. Does the 3 want to go towards the 2 over there or away from it? It wants to go away. So the force on the 3 is going to be left away from the 6, left away from the 2. It's going left. What about determine the force on the positive 6? This is going to be the toughest one. This just means micro. We don't really need that right now. Determine the force on the positive 6 due to the other 2 charges. This is the hard one. What does that 6 want to do? Here's what's really tricky. The 6 wants to go, well, does the 6 want to go towards the 3 or away from it? Does the 6 want to go towards the 3 or away from it? It wants to go away. But does the 6 want to go towards the 2 or away from it? And it wants to go away. So this is confusing. The 6 wants to go right away from the 3, but it wants to go left away from the 2. So if the 6 wants to go right away from the 3 and left away from the 2, who's going to win? Well, this is going to be the bigger one. So what's going to happen here is that the 6 is going right away from the 3, but left away from the 2, but it's the right's going to win. So this is going to end up being right. Because right wins. The last one would be, what does the 2 want to do? Which way does the 2 want to go? So if I said for the last one, determine the force on the 2. Due to the other. If I did this one, determine the force on the 2 due to the other charges. Well, this one's pretty easy. That 2 is positive. Does it want to go towards these positives or away from it? Away. So the 2 is going right. Right, all right, right wins. So the question is here, when you have multiple charges, just say, hey, look, what does this one want to do? The 6 was the tricky one. The 6 is getting pushed to the right away from the 3, but it's getting pushed to the left away from the 2. The 3 is going to win. So the 6 is going to end up going right. Does it make sense? So good luck with your homework tonight. And that should be good enough for that. And we'll check that on day 3.